development, as I was saying earlier, rural assets as a part of Geo-Manrega, Mahatma Gandhi National Rural Employment Guarantee Act. So several assets are created under several schemes, PM Krishi Sinchai Yojana, Rashtriya Krishi Sinchai Yojana, etc. So all these assets, I think it is roughly 3.59 crores. 3.59 crores of assets are available, and they are all geo-tagged through our mobile app, and all these are residing on our Bhuvan server. Okay, so that means what are the assets? Just to name a few, they can be school, primary school center, or primary health care centers, panchayat offices, or farm ponds, or check dams, or other infrastructure components, etc. I think some 17 categories of assets are captured as part of this project. So this geotagged data is available, and anyway the spatial layers are with us only. Okay, and now the next thing is SDP, the bottom right, space-based inputs for decentralized planning. Decentralized planning. Now the planning is done at country level, agreed. But at a village level, if I have to do planning, what are the resources available? What is the infrastructure available? How I can improve my village with the participation of the local people, considering the local conditions, considering the limitations or political practice or whatever. So you can make your own plan, and that is where the technological layers will also help us to draw a good plan. So SysDP is such a program, and it is done at a 1:10,000 scale. Okay. And water is not handled properly, or recharge is not happening, watershed is not performing as expected for various reasons. So for that, you try to construct some percolation tanks or check dams or farm ponds or whatever, so that water practices are well maintained, and water what you call recharge. Water recharge is also happening. So these projects are taken up. What is happening? They need to be monitored whether they are happening or not in the field. Funds are given, but are they happening? So that monitoring part we are doing through satellite data, coupled with this geotagged information obtained through our mobile apps. Next. And as a part of rural development, now several villages, they are not connected with a road. So from the nearest main road or say highway or whatever, the objective is every village should be connected by a road, which is motorable. That is the plan of Government of India. So new roads are being laid, and that is Pradhan Mantri Gram Sadak Yojana, PMGSY. So under that, now what are the roads, what are the stretches which are built in the last 1 month? So it is the local people give their report. Even if it is done partially, they simply say it is done. But from satellite data, we are verifying periodically and certifying that these are the roads laid for which payment is made. So everything is connected to financial payments. So we are monitoring in this project. And next thing is disaster management support. As I said earlier, flood, cyclone, forest fire, we discussed these, landslide also, earthquake. So these are the major natural disasters. In case of these events, what are the areas which are affected, what are the areas which are inundated in case of cyclone and flood? So this is very prominent activity every year. Every year somewhere or other good number of damage is taking place. So it is about 10-15 days of event. Every event means 10-15 days. So what are the areas which are inundated, we are capturing, and also helping the local authorities to do the necessary measures or relief operations. Okay. And forest fire I discussed, landslide I discussed also. Earthquake also, yes, whenever there is an earthquake, after the event, we are doing postmortem only. After the event, what happened? That's what we are capturing and giving the information to the government. Next please. So these are all this we discuss. Forest fire, landslide. And there is one is called, as a part of disaster management support, National Database for Emergency Management (NDEM). There is a separate portal which is made available and with restricted access. And the Ministry of Home Affairs is directly working on this. So we are working as per their requirements. So all the infrastructure elements as well as inundation information, everything related to disasters is archived exclusively under NDEM portal, and all the state governments have access to this. In case of crisis, they will be able to use. Essentially, it has the information layers prior to the event, during the event. So that gives you the change. What is the change that happened? So that helps to assess what is going on. Next. Now, institutional engagement or hand-holding. I was touching upon this point earlier. So we provide a lot of training programs, capacity building across the country to several institutes. In addition, whatever big projects we are doing, if that particular organization is interested to continue forward with their own manpower internally, we institutionalization by hand-holding. So we train them, and they will purchase suitable softwares, hardware, etc. We give them a training, maybe 1 year, 2 years, we do hand-holding so that they are on their own to continue the project. So that is one important activity going on. And in these sector-wise, agriculture, water, land, urban, forests, energy, disasters, in all these sectors with respective ministries, and those are the government schemes under which we have been working. So I am not reading out those, it's a big list. Next. Now somebody was asking about data. This is the Bhunidhi portal. You can register and log in yourself and download whatever data sets you want for your requirement. Next. And these are the global open source satellite data sources. So these are the data sources for different types of satellite data. All this is freely available from internet. So you can download as per your requirement. They are our Indian satellite as well as foreign satellites, all are there. Next. This is the DM data sets, digital elevation model data sets. You have from Cartosat, that is our own, and you have Aster data, and this is SRTM, Shuttle Radar Topographic Mission. And SRTM is a 90 meters data, whereas Aster is 30 meters, Cartosat is also 30 meters. They are also available for you to see. Next. Satellite aerial UAV. This is a platform related. When you say remote sensing, what are the multiple platforms? I briefly touched in the beginning. So satellite platform, airborne platform, and a low altitude UAV. Everyone has its own pros and cons, but it depends on your specific application and the cost, financial part, urgency part, and if it is a crisis and short area is to be covered and it has to be done in 1 or 2 days, probably UAV can be done. Whereas aerial platform, it requires a reasonable planning and weather should cooperate. That is very important. And DGCA clearances are required, etc. There is a big procedure. So we have aerial remote sensing also in NRSC. So UAV also we started in the recent past. Of course, satellite platform, all of you are already aware, we discussed enough. Next. So this is open web platforms, Earth observation, data management and analysis. There are several data availability from different sources. I just listed out here. Next. So with that I conclude the applications part. So I will just take you through the contribution or potential of AI in the next 5 minutes. Now when you talk about AML, normally you must have heard several algorithms. So now what are the ML algorithms which are amenable for remote sensing applications? So in that context, I am just listing out a few. So regression, neural networks, support vector machines, symbolic or decision trees, random forest, etc. And nearest neighborhood or name-based theorem or name-based algorithm. These are some of the algorithms which are well used for remote sensing applications. And the performance of algorithm is evaluated based on those metrics, mean absolute error, standard error, etc. I'm not getting into the details. Next one. Because every algorithm, if people now, I think all are engineering students, I have a suggestion here. Those who are working on AIML, particularly under data science, try to understand the mathematical principles behind these algorithms. Generally, algorithm is taken, Python libraries are there, you simply import the library and use the functions and go for it. But mathematical principle of the algorithm, if you know, you will be more successful. Because now each algorithm I can explain mathematics. I am very good at that. That's why I am saying, being engineering students, please try to understand mathematics of this, or the statistics of it. Then you will be successful in your career. Whoever is from AIML students, this is my suggestion. Because that is the real beauty. Being an engineer, you should know that. You for beautiful career in future. I am myself very good in that. That's why I am saying. I spent substantial time to understand the mathematics of these algorithms. Okay. So now this is one case study using AIML. So delineation of oil spill. Oil spill means in oceans, whenever there is oil tankers being transported, there is a possibility that some oil slick happens. And entire surface of the ocean is crowded with oil, and it is a sort of disaster. So now what is the extent of such oil spill? That is done, and normally we use microwave data for this purpose because the backscatter is a bit different, because the background is water, ocean water. Whenever oil is there, because of its viscosity and density, the reflectance backscatter is slightly different, and that is what is picked up in microwave. Now this is the general concept, but this concept we can also apply using ML. So that is what our people experimented, and the results are encouraging. And this, if we extend for larger areas, and we can try to generalize this application for a different scenario. Okay, this is one potential application of AI. Next. The same thing. Next. Now these are the algorithms, convolution neural network model or linear or logistic regression model. They are adopted in this, and both algorithms are verified, which is giving better results in this oil spill application. So the accuracies and all are listed. Next. Now LUFC classification. There are several classes. There are 2 or 3 types of classification schema. At the highest level, I think some 8 classes or so are classified. And in a second level, roughly 16 classes are classified. And at a very high resolution or very high detail level means from 52 or so classes are classified as a part of LUFC. So it depends on your requirement. So now, this is experimented for about 5 to 10 LUFC classes using these ML algorithms. Initial results are good. There is a good potential to develop this. And here the advantage is you have labeled data. Already LUFC is mapped. It's a labeled data. So you can experiment and you can extend to other sites and test your algorithm. And so many features are there. Either you handle all the features at a time or 1 or 2 features at a time. You can design your experiment accordingly. Next. Now these are the input data sets for LUFC. Next. This is one more road extraction from high resolution data. High resolution data is used to extract data, but in the same context, whether can I use A? So here UNet algorithm is experimental for this purpose, and the results are good. but I really I cannot comment because I do not have full detail here. But it is good, initial results are good, but to be verified in a more number of areas. But initial results are good. Next. Hotspot analysis. What is hotspot? Now, let's say now here there is an agricultural land somewhere. Every year it is an agricultural land, but suddenly in some year there comes a big industry. Now agricultural land is transformed into an industry or whatever. So like that, are there any hotspots, sudden changes in the land use? If so, can I pick up by using my ML algorithms? So that is one important thing, to understand what are the sudden changes which are called hotspots across the large area. Now one or two small pockets you may come to know from some source that there is something is happening there. But can I do it across a state or across a nation? So there you can apply AI techniques. Next. Geospatial data science. Now this is the topic what you are going to talk in the next 5 days. So here how best you can employ these deep learning techniques for different applications. So whatever applications I have been discussing for last 1.5 hours, almost in every application, or at least 50% of the applications, there is a scope for applying deep learning algorithms and try for a better solution. The reason being, you have good data volume, there is also labeling of the data, that means you have good training data set available with you. What you need to do is just check it, fix a model or try with 2-3 models and test it on certain areas, validate yourself and finalize. So that experimentation needs to be done. So there is a potential for good number of applications. Next. Now this there is a brick kiln. Now there are brick kilns across. Can I identify using ML? So that is one attempt made. Similarly, trees. How many trees are there? You ignore forest part. Outside forest, how many trees are there? This is one of the requirements of the ministry. So physical counting is difficult. So from data, can I do it? If so, can I do it using AI? So an experiment has been done. It is progressing. This project is going on. Okay, next. Now this is a yield estimate in agriculture. I was discussing on this yield estimate. So yield is a function of certain parameters. Now all these parameters, if I have to handle in the conventional system, there are certain limitations of dimensions. Multiple dimensions, multiple criteria, so our conventional systems may not be so great. So that's where we can think of applying AI models. Next. So here our people, they tried in crop yield estimation using neural networks, and they have tried with random forest, and results are encouraging. I think very soon they should be able to generalize in a bigger way. So this is one successful activity. As of now, it is successful. So these are some of the case studies or examples of AI, just to make a beginning. And there is enormous scope. As I said, there is a huge volume of geospatial data. There is also parallelly huge volume of field data or point data. So if you can collaborate and adopt AI, definitely you can make beautiful solutions which can be operated at a larger area, at a national level, etc. And that will be very useful for the country, for future policy making, and also for industries to have a new business opportunities. And academicians have a good amount of role here. They can formulate good research problems from this and work on this. If required, 2-3 teams can collaborate and start working to derive a solution. Only thing is, please strive for a solution. That is important. Keep your objective for an effective end use. That is one suggestion I can give. Academicians normally, they are not so keen on end use. They just formulate a problem and go ahead. Maybe they may publish a paper and close. But that is not going to be useful. Particularly the government is particular. They will fund if your solution is expected to be of use. So please formulate your problems such that they have some end use somewhere. Then you will be respected and you will be also supported with funding. That is the general understanding. So try to orient your research in that context. Paper publishing anyway it will happen as a part of the work, no problem. But your objective should be defined like that. Okay. So any questions? If nothing, I can stop here. Any queries?
Which performance metrics?
Which one?
You have shown some performance metrics.
Correct.
That specifically mentioned as inch.
Correct. I think maybe I will stop. Anyway, more details are coming up. Maybe she is also touching. Maybe she will get into some details. And I think Radhika will be coming later. Okay, I think we will stop here. I think maybe she can take next. Thank you. Thank you very much.
Thank you, sir, for giving us a deep understanding on the topic. That was really a spectacular session. Now, it is time we introduce our next guest speaker of the day, Dr. Cse-Aiml, scientist at NRSC ISRO, to share her insights on the topic, geospatial technologies and applications. Welcome, ma'am.
Good afternoon, everybody. It's always tough to take lecture before lunch, and I think time is also less, 30 minutes only. So I'll try to do justice. And it's a new topic for you all, geospatial. So rather dwelling more into it, I'll try to make it more interactive so that all of you will get interested in what I say. Also, I will share experiences and things which you will not get on the internet, because theory you may get on the internet, these days everything is available. So I will try to keep it more interactive with my experiences and some case studies and a generic presentation. And you are free to ask your doubts and questions. So let me make it more interactive. Having learned about the geospatial applications, what we are getting from remote sensing data, the different type of works, projects we can take with geospatial data. All these days, from 1995 onwards, when we started Earth observation or acquiring this remote sensing data, we are doing using traditional methods. But now, as was told in the inaugural session also, since we have enormous data available with us, and it is continuously we are acquiring on the order of terabytes daily, huge computational power, and the new advent of technologies enabled us to use more intelligent driven methods like artificial intelligence, deep learning, machine learning to these applications, so that we can automate the entire chain, we can get results in a faster pace, we can reduce manual dependency, manual bias, and also errors. So those are the motives which have allowed us or inspired us to use these newer technologies on these datasets available to us. We can apply these methods on whatever we have seen in the previous session, on all those applications. Some of the applications we have already applied are, I'll tell you some examples. We have used Cse-Aiml on ship detection, like how sir told, YOLO Vjit, new algorithm, then solar vision, solar parks, solar panels, we have used AI, trees detection, forests, cloud coverage, because remote sensing is of basically two types, active and passive. Passive, where we are using solar, sun energy as a main source of energy, And somebody was asking question like, why we cannot have models for tsunami. So first of all, I'll tell you, the entire remote sensing is based on the principle of reflectance, reflectivity. We assume that whatever energy is falling, be it solar energy or our own radars, our own energy sources, whatever energy is falling on different features, say atmosphere, land features or ocean, it is 100% reflected back. And that on the principle of reflectivity, whatever energy is falling on different objects, it is reflected back, it is captured by onboard sensors which are present on the satellites or aircrafts, and then it is again transmitted to our earth stations where we process what is there. Everything is digital data these days, 1 and 0, what we use cameras. So everything is digital data, we process that digital data into analog and then we find out what was the feature. Whether it is the energy is reflected by urban developed area or some forest or some trees or water bodies. So based on this reflected patterns or spectral signatures, we identify what feature it is. So for water bodies, the entire energy is absorbed. That's why ocean appears dark. The big water bodies appear dark because entire energy is absorbed by this, nothing is reflected. And whatever band it is reflected, like I was telling about RGB, red, green, blue. So if green band is reflected, we say it is trees or forest cover. Now these stairs are reflecting, it is appearing in red. Electromagnetic spectrum, entire spectrum, which starts from X-ray, thermal, microwave, optical band, near infrared, shortwave infrared. So when we use optical band and such source of energy, we say it's passive remote sensing because we can only do when sunlight is good. We cannot do during floods. Yeah, I'll check. I'm just giving a general idea before going into exact presentation, so it's a general overview. So we cannot do this passive remote sensing or baseline source of energy during night times or during when the sun illumination intensity is not good or during floods, during rainy season, etc. On such cases for droughts, you might remember when sun shows you about the ship detection, or in the case of floods, since sun is not there, it is cloudy, an optical band does not have that much wavelength to penetrate through the clouds. So we need an alternative source, and that's why we felt the requirement of active remote sensing, where the sensors have got its own source of energy, not sun. So we say radar, RISAT-1 group of satellites, where they work on microwave band of electromagnetic spectrum, which has got more wavelength. It can penetrate through clouds, even penetrate through the canopy of the trees, etc. And it's an all-weather satellites because it has got its own source of energy. It works day and night in all-weather conditions. So during floods, etc., or for such applications like ships and all, where penetration is more required, we go for microwave band of electromagnetic spectrum and we say active remote sensing. Depending on the applications, say suppose we have to do fisheries or ocean-based studies, we select that particular band of electromagnetic spectrum. Like if we have to study fisheries, we know fishes, they are cold-blooded animals. They always go towards the warm current, and also some food also should be present for them to eat. So what band we select? We select vegetation, green band or near infrared for vegetation, and the thermal band if we have to find out fish zone. So based on the application, we select that particular band of electromagnetic spectrum, those sensors, and what should the resolution, all those things we select based on our application, what we want. So AI has got its role in almost all the applications of remote sensing, be it land use, classification, segmentation, shift detection, trees, or solar parks, or trend analysis, or climatic patterns, because now we have huge data. If we train our models of how how global warming is happening, or what about the rainfall trend in last 15 years, the model will allow us to predict for the next 5 years what should be the trend of global warming, rainfall patterns, pollutant like carbon dioxide, carbon monoxide, all those things we can predict using our AI. So these are some of the projects which are already happening. Also, somebody was asking about tsunami. So, cyclones now, about the disasters which NRC is studying. We have cyclones, we have landslides, forest fires, floods, droughts. So, for cyclone is one such disaster where, with the availability of good data with us and the models which we have made using these data, at least 5 days in advance, we are able to predict every information about the cyclone. Where it is, where the landfall is expected, what is the velocity, how it is progressing, wind speed, everything is known at least 5 days before the cyclone happens. And that's why we have reached to zero life losses. And we have, India has got a certificate also from UN almost 3 years back that India has reached to zero life losses due to application of AI, good model prediction, and the data which is available with us. So this is how we are applying AI for all these applications. Okay, and the models, everything is now there, most of the things are there. Python open source libraries are available. It is up to us how to use that data, train our models, and fine tune that model based on the application. So one such application I will just discuss with you. Tsunami also somebody was asking question. So we have, I said cyclone and forest fire because of modest daily coverage, thermal data. We are predicting in advance about the forest fires, about the cyclones. Landslides also we have good data. Tsunami also, there is one sister concern of us in COIS. They are doing good work using AI and they are making good models also on tsunami, but it's as certain, since it is under ocean where everything is absorbed, normally Earth observation signals may not be enough. We have to use sonar data or other data sets also to make such good models. Coming to forest fire, I discussed some questions. Yeah, some indices also we have, like vegetation index, indices, or built-up area, or water body. So based on all these things, all those technology which are available with us, data we are available with us, we are applying. Like some of the students, they have applied vegetation. Some studies they have to do based on where development is more. So they have used in the Himalayan regions. So they have used vegetation index, built-up area index, and water bodies, NDVI, NDBI, NDWI. And based on these differences in these indices with the data, remote sensing data available to us, using AI models, we can find out, we can do a probability study of how things are coming up. Similarly with the solar panels, solar parks also. I got one such, just an overview of one study about agriculture, because India being our agriculture driven, our economy is basically an agriculture driven economy. Most of the applications we are concentrating on agriculture patterns. So here there's one study how we are doing, and somebody was asking question also how we can apply AI for agriculture studies. I'll just try to go with that. Time is also limited. So like previous slide. And sustainable development goals, if we address to those, one major factor for us to use AI is timely data and timely decision making power, because whatever we do, we should have good decision support systems, and we should have mechanism to get decisions of how we can go for sustainable development goals, how we can increase food security, water security. So all such timely decisions AI is helping us to make. And that's why we are using this AI for agriculture, we can use for disaster management, as I already told, we can use for urban planning, environmental monitoring and climate changes, we are doing for pollutants, we are doing for global warming, all that we are using AI now, and water resource management also. These are some basic areas I have listed here, but we can apply AI for all the things. I am just going deep into agriculture. Next slide please, maybe we can skip the next slide also. Yeah, here, one slide. a generalized framework, how we can apply AI for agriculture. We are getting data through satellite imagery or through airborne. Lot of open source sites are available now. Like if somebody wants to start afresh, they can go to internet and lot of Landsat, Sentinel, ResourceSat, List3, AWIF data is available freely downloadable. So those data sets can be downloaded and can be applied through the models, and then you can fine tune the models with the more higher resolution data sets like RSAT. So we acquire data, we pre-process because lot of your satellite is moving, Earth is moving, Earth is having a curvature, so lot of errors are there in the data when we receive it. We say geometric or radiometric errors. So there are tools, softwares available where you can remove these errors. Data gets error because of atmosphere, lot of pollutants are there which absorbs data like water molecules. Data gets absorbed, some things are added to that data. So we have to pre-process to remove all these errors or reduce all these errors. And then we apply these models, Cse-Aiml models, using these data sets, what we have acquired and we have pre-processed. So we apply AI models into it for different patterns like crop classification based on the soil content, soil type, soil moisture, water content. We can apply the models for crop class, which type of crops can be grown in which area, what soil content is required, and for yield prediction, how much yield can be predicted based on previous trends, and training our data with those trends. In fact, now one application has happened. I'm into academia collaboration, so I'll just tell you those things also. One of the application we did with our students, where for a particular soil and particular crop, if we have trained the model to have that much moisture in the soil, after that much moisture, automatically we are watering the soil, it will stop automatically. Because we have trained the model that this crop and this soil requires only this much moisture. So we are saving water as well as we are saving the soil parameters also. And for pest diseases, because we know how much nutrition is required for a particular combination of soil and crop, we can also build this intelligence into the model so that these many nutrients are required for pest detection, and for this crop can be affected with these pests, so these nutrients or fertilizers in this amount is required. So all this intelligence can be made up into these models. Then with all this what we are doing, I told you the final output should be a good output as well as a decision support system which allows us to take decisions and fine tune our model to get a good yield. So we can have a monitoring dashboard, we can have some alert systems, we are also doing crowdsourcing so that we can get feedback from the people who have used that similar type of combinations, and all that can be again in a feedback loop. People who have worked on AI may get some idea, otherwise also for beginners, you can have some feedback loop, different type of models are available. So now like generative adversarial models, which depends on generator and discriminator. So you have a feedback loop where you can continuously train your model depending on the feedback what you are getting from your decision support system. So this is how you can again fine tune a model. Just one more point back. And resource optimization tools, as I told you, for water, just now, water or for pest or fertilizers. Next slide, please. Then you can have a continuous improvement using field validation, your ground truth values. You can always go to the field and suppose you are applying this model for a bigger area, say 10 kilometers, similar type of crop, such as sugarcane. You can go to a nearby field and you can find out how the things are exactly going. Some 2-3 fields you can go, and based on that, you can do the validation part of it. And different type of matrices are available based on the different studies. Not all matrices are available or are required or are correct for one particular study. What application you are doing, based on that you have to select the appropriate matrix. Anyway, mean square error, MSE or Sse-Aiml structures, symmetric index matrix, these can be applied for all the things, but otherwise coefficients are there or different matrices. This depends on the application for what you are applying AI. So user feedback loop and then policy integration, and then other social and ethical considerations like data privacy and security, because everything is, in a way now we are working in an open source domain, but still privacy can be built using your cloud architecture. So you can make some things public, some things private. So it depends on what study you are. You can get the advantage of what people are doing around you, but same time what private you want to keep, you can keep using a cloud sort of architecture. And inclusivity and environmental respect. Yeah, next slide. And just have one case study. Next slide. One second. So you can have increased crop yields, you can have food security, which helps you to have sustainable development growth and improve resource management, and all those things are there. Such type of models, it's common to use for developed countries like US, UK, etc. But one such countries, African country, they have used this model and they have increased their yield by almost 90%. I'll just have that thing also. Please, next slide. Sub-Saharan African country, they have used this AI and satellite data model and they have increased their yield by 90%, the accuracy of 90%, and also about 70% of the rural population they are able to feed have the employment as well as the economic growth of the rural population. Offering, in fact, many centers of ISRO, they are offering student projects or internship programs, or faculty also can join us, research scholars can join us. You can write to us, you can join us for your internship programs, for your projects and faculty development things also, right from a period of 30 days to 1 year, and where you can be a part of our ongoing projects or different innovative ideas, research proposals, and you will be allowed to work on the real satellite data which is available with under the guidance of the scientists. And suppose some faculty in their summer vacation you are doing some work in the field of agriculture, also disaster, and you want to learn something more or upgrade or venture into a new area, you can write to us. Everything is available on NRSC website, nrsc.go.in, under student project internship program. Everything is available. So you can write to us, apply to us, students, faculties, everybody, research scholars, and you can be with us for this particular study. So this is one thing, and as told by my previous speaker, you can all enroll to Bhuvan. It's an ISRO Geo portal where free registration is there both on Bhuvan and Bhunidhi. Bhuvan, you can visualize your own applications. I'm just giving one or two lines. Lectures are there again. Stop it. Stop. Bhuvan, you can visualize using the data sets available there. Before you start your own thing, you can just have some idea. And if you want to download some data, you can download from Bhunidhi.
Hello, you are seeing a geospatial chatbot. It is designed and developed at NRSC. Let me briefly introduce it to you before the live demonstration, as this will help in better understanding. This
any guidance you require in this area, and with the new space policy, geospatial policy, most of the data is freely available. You can also use our own ISRO infrastructure to build your own startups. So you can, your space is free for you, space is available for you, it's up to you to use it, utilize it. And just one application where we have used cutting edge technology, NLP, large language models, generative AI, and near real-time geospatial data analysis. We have used all this. Me with my students, BTech students, we have developed this application, just a small video to give a glimpse of how we are doing. This is an innovative project where we are saying it's a geospatial chatbot. So where voice assistant chatbots also we have done using generative AI, but this is where we are using geospatial analysis also, where any user in its own native language, like you can ask in Kannada any question you can ask about the water spread of that particular reservoir which is available in your locality. All large and medium scale reservoirs are databases made for those large, around 1,000 reservoirs are there. You can select also, it's available in text and audio mode. You can either select or you can speak in your own native language. I want to know, say I want to say, मैं हिंदी में पूछ रही हूँ कि मुझे हिमायत सागर का जल स्तर पिछले 5 सालों में कितना था. कोई भी लेमन भी क्वेश्चन पूछ सकता है. उसको ना तो कंप्यूटर की नॉलेज होना ज़रूरी है, ना ही उसको ये बज़वर्ड्स ज़रूरी है. In its own native language they can ask. The system will analyze what the user has spoken using LLMs, NLP, do the geospatial analysis using data, and again answer the query in the own native language using all that spatial history. I'll just show you that particular action. This is one such application which our BTech students have done with us at NRSC. So this to give you an idea and inspire you how we all can collaborate and do such projects. I invite all of you to come to us and then work together. I'll just show this application. Yeah, we can play.
Hello, you are seeing a geospatial chatbot. It is designed and developed at NRSC. Let me briefly introduce it to you before the live demonstration, as this will help in better understanding. This geospatial chatbot processes the user query using satellite data and provides the output in near real time. The salient features of the project are, it works in both text and voice mode. It works in multilingual mode. The user can ask a query in their own native language, and the reply is also provided in the same native language along with graphical and map representations. Bar graphs are used to demonstrate historical trends. Time-lapse or trend analysis is shown pictorially. The reservoirs of the entire country are shown spatially in the Indian map, which will help the user in locating their area of interest. For the new users, a help is also provided for forming their query. Now, let's observe the video of its working. Hello, you are seeing the geospatial chatbot. It is designed and developed at NRSC. Let me briefly introduce it to you before the live demonstration, as this will help in better understanding.
Hello, you are seeing the geospatial chatbot. It is designed. Hello, you are seeing the geospatial chatbot. It is designed and developed at NRSC. Let me briefly introduce it to you before the live demonstration, as this will help in better understanding. This geospatial chatbot processes the user query using satellite data and provides the output in near real time. The salient features of the project are, it works in both text and voice mode. It works in multilingual mode. The user can ask a query in their own native language, and the reply is also provided in the same native language along with graphical and map representations. Bar graphs are used to demonstrate historical trends. Time-lapse or trend analysis is shown pictorially. The reservoirs of the entire country are shown spatially in the Indian map, which will help the user in locating their area of interest. For the new users, a help is also provided for forming their query. Now, let's observe the video of its working. Please ask your query. What is the water spread of Pocharam during 2024? Thank you for using our application. The query asks us, what is the water spread of Pocharam during 2024? Processing your query. Analysis is going on. Retrieving the satellite data. Please wait for the results.
These are some potential applications of AI. Whatever you can envisage, now you can apply here for that particular application. So just start. And thanks from me for today. I think I could do justice in the half an hour provided to me. Thank you very much. Any questions you can ask me during lunchtime, or now also you can ask. Any questions? I think it's lunchtime. After lunch also I am available for some time. During lunch also we can discuss. Later also. My number is also there on the website. You can always contact me. Thank you very much.
Thank you, ma'am, for sharing your keen insights and different aspects on the agenda with us. Let us once again give a huge round of applause to our incredible speakers for being the GPS of today's seminar, guiding us to the world of geospatial technology with precision and clarity. Thank you, ma'am. Thank you, sir.
Everyone is hereby requested to proceed to the lunch break. Please take this opportunity to enjoy your meal, relax and network. We will reconvene shortly at 1:45 in the B block 201. Gather around after having your lunch. We'll be taking you to the destination. Thank you.